Hi everyone, welcome to Langchain version 1 agents tutorial series. Previously, we have covered our Langchain version 1 projects. After a successful coverage over the Langchain version 1 projects, which you can see here, let me just show you quickly. Langchain version 1 project. You need to come here in the repository, Langchain version 1 projects. After the successful implementation of the Langchain version 1 projects, now we are going to start Langchain version 1 agents. For Langchain version 1 projects, we already have a playlist which you can watch here, Langchain version 1 projects. Once Langchain version 1 agents videos are prepared, then I'll also prepare a playlist on my YouTube channel, which you can come here at the KGP Talkie and then you can watch. Recently, Langchain has announced that they are going to launch version 1 of their Langchain repository, basically, or Langchain the package. So they have made their series of the changes, and those changes we are going to cover specifically, which are related to the agents. They have made so many changes. So all those changes we are going to cover in this particular lesson. Let me, in fact, in this particular series of the lessons, or you can say that in this particular playlist, we will be using here the Ollama, and I already have installed the Ollama. Here it is up and running. And again, if you do not have the Ollama or you do not have the knowledge of the Ollama, you can come to my KGP Talkie channel. There you have a tutorial related to the local LLM tutorial. There I have shown how you can work with the Ollama. Let's come back to the presentation. In presentation, we see here that there are three important things with the tool, in fact, with the agent, which we need. That is the prompt, tools, and the LLM. Once we have all these three together, then you have an intelligent agent. So what are the changes which Langchain version 1 has made in their recent release? That earlier agent was present in the Langgraph, but now agent is present in the Langchain, and also it is pretty much optimized, and it is also like very simple to implement. Earlier, it used to take a lot of effort to implement the agent, but now it is gonna be super simple. All right, and also it provides a lot of the additional flexibility, or additional, you can say, the configuration, which we will be learning across this playlist. So we'll start with the very simple and the very basic, that how you can implement one of the simplest agent. We will be using here the tool, as I told you here, that to implement an agent, you need there the LLM tool and the prompt. So these three things are the one of the most important thing which you need with the with the agent. All right. So in the form of the LLM which we have here, we will be using the Qwen 3, and also we'll be using here the GPT OSS, that is the open source model provided by the OpenAI. I'll be also showing you later on in some of these lessons how you can dynamically select one of these models. So all these features have been provided by the Langchain in their version 1. And then later on, I'll be also providing you how you can actually select these prompts dynamically. Later on, you will see in these tutorials that how you are going to select these prompts dynamically. Having said that, let's go ahead and start coding. So I'm just going to close this presentation, and then I'm going to show you here, the first of all, how you can install this pre-release version of the Langchain. At the time of the recording this video, Langchain version 1 is not released yet, but that is available in the pre-release version. If you are using a pip, you can install Langchain pre-release version using this particular command, pip install --pre, then upgrade Langchain, Langchain community, Langchain core, and the Langgraph. Similarly, if you are using the using the UV is pretty much simple actually. So what you have to do here, you can first install the UV itself, like pip install UV, and thereafter you can work with the UV. UV is a Python package manager. It is pretty much simple. Let me just search here the UV, and here you have this. This is super fast and super easy to work with this. You need to click on the Windows, or as per your the convenience, like if you have a Mac OS or the Linux, and then follow this particular instruction, then you will be having UV installed in your computer. Once you have UV up and running, thereafter you can just simply write there the UV init, Once you write there the UV init like this, UV init, it will initialize the project. It is going to initialize the project like this, where you will be having the UV log, PyProject toml file, main.py file, and so many other things. Thereafter, you can just simply install it using the UV add pre-release equal to the allow, and then -u Langchain community, Langchain core, and the Langgraph. All these things are going to install the pre-release version. So in the pre-release version, you will be having a Langchain version 1 installed in your computer. So if you see this pyproject.toml file, then you will see here that the Langchain, let me just see, where is the Langchain? Yeah, here it is, the Langchain. So you see here the Langchain version 1 alpha release is currently in the production. So you will see you have here the Langchain version 1. Once it is released in the stable mode, then you can just simply use the UV add without this pre-release, Langchain community, Langchain core, and the Langgraph. Let's go ahead and see the structure of the agent, which we are going to implement here. How we are going to implement all these things, I'm going to show you. So the first of all, you need to understand that how actually agents are implemented. Suppose that user have a query. So the query comes from here, where you have your query. Let's say this is, I'm going to say that the user query. Once user have a query, then this query goes to the LLM. So that LLM here, I'm just going to say that here you have your LLM. So this is something which I say that the LLM. So as LLM is actually the thoughtful. So this is going to think about something. All right. So LLM is going to think whether it is going to call a tool or not. So basically what happened, LLM calls here a tool. All right. So the tools are something which agent cannot, basically it is like the set of the operation basically. So the some set of the operation agent cannot do. And those operations can be done by these tools. So the LLM call these tools, then you come to this tool. Once tool is called, then the LLM returns the result from these tools. All right. Basically, these tools are returning the result to the LLM. All right. So the tool return the result to the LLM. And after that, LLM analyze the result given by the tool, whether it need to finish it or not. All right. So if it decides to finish it, then it generates the answer here. That's the final answer basically. All right. Let's go ahead and see what are these things. So first, this one, you can say that this is going to be the action. All right. And what you see here, this one is like the observation. All right. So this is your observation. Or you can say that LLM has got the response from the tool. And then LLM decides whether it need to call again a tool or not. If it decides that, no, I don't need to call the tool, I can produce the final answer, then it finally produces the final answer, which you can say that it is going to finish it. So this is the overall architecture. All right. In this, you will notice here your LLM is getting the user query, and the LLM must be having some kind of the prompt as well. All right. So you can say that here LLM is also having here a prompt. You can see that this is like the system prompts and the user prompts. So I'm just going to say that this is like the set of the prompts. So LLM have these prompts as well. All right. Now you have your LLM, you have your prompts, you have your tool together. Once you have all these together, then you say that you have implemented here agent. So this whole thing, what you see here currently, that becomes the agent basically. And then finally your agent produces here the answer. Let me just bring it to back so that we can see here that bring to back. All right. Now you have here, let me just give here another color. Maybe I should be giving a different color probably. Yeah, this is the good one. Okay. So now you have here, you have user query that goes to the agent. Now I can see that this overall implementation is actually the agent. So I say that here, this is actually the agent. What you have here currently, this is the agent. So your agent is going to have here the LLM, your agent is going to have here the prompt, your agent is going to have here the tools. All right. This is one of the simplest form. Perfect. So in the one of the simplest form, the Langchain have this agent implementation. here, if you look there, then it is going to be called as the one of the simplest thing, that is going to be the create agent. Earlier, we used to call create react agent from the langgraph.prebuilt, but now we are going to call it from the Langchain. So basically, it is going to be like this only. From langchain.agents, import create agent. Thereafter, we are just going to simply create our agent. This is going to be the super simple and super easy for us. So how we create this? First of all, we import our create agent, and we are also going to import the tools here. Why tool? Because you see here in our agent implementation, we have our tools as well. All right. So the tools, for the tool, you have to use there the tool decorator. All right. So that you can convert one of the simple, the Python method into the tool. So that is why we import here the tools as well. All right. Perfect. But this particular tool is not coming from the Langchain itself, but in fact, I have implemented this tool into a different .py project here, .py file. That's the tools.py. Why I have implemented? Because you see here, I have basically I'm going to use here so many tools across these projects. So at least 10 to 9 tools I'll be using here. So what I did here, I created one Python file which is going to have all the tools, so that I can import these tools in any of these notebook whenever I need this. So basically, I have centralized my all the tools. So I'll be showing you all the tools implementation as I move forward in this particular playlist. All right, having said that, now, before I import this tool, I have to also implement my tool here. So what are the tool we have here for the implementation? Let me just show you this in my presentation. So in the presentation, you will notice here that apart from these technology stacks, you will see these are the tools. So I have total 10 number of the tools. So I'm going to implement here the wave search tool first of all, so that we can get the real-time information. All right. So to get the real-time information, we will be implementing web search using the DuckDuckGo. So the DuckDuckGo is a free version and it is the API free. Basically, you can just install the DuckDuckGo and then you can use this DuckDuckGo. So to install the DuckDuckGo, what you have to do here, you have to make sure that you write like this, UV add DDGS. All right. So this is the DuckDuckGo search. So you have to do like this. Then you will notice this DDGS will get added into the pyproject.toml. Here you will notice. All right. Perfect. So this is how you install the DuckDuckGo. Once you install the DuckDuckGo, then you can start implementing the DuckDuckGo here. Let's go ahead and see our DuckDuckGo, the site here. So I write here the DDGS PyPy. Let's go ahead and search this DDGS PyPy. Here it comes, DuckDuckGo. Then they say that there is the new package. Basically, this is the DDGS 9.60 currently at the time of the recording. All right, then you install it. After installing, you scroll it down, you will see all kind of the usage which you can do here. So they provide all these things there, like you have a query, you can select the region if you want to perform any specific, if you want to perform the search for any specific region, then they have the language to select, then they have the max result, and they also have there the backend. So they have so many type of the backend actually. So currently here only the 2 is listed, but later on you will see they have so many type of the backend here. They have a Bing, they have a Brave, DuckDuckGo itself, Google, Mojik, and there are so many. So you can use any of these backend if you want, or you can select these backend with the comma provided. Basically, you can pass there the backend equal to then the name of your search engines which you want to provide. And if you have any kind of the proxy, etc., you want to send information from some kind of the proxy, then you can also use those proxy as well. All right. Having said that, and I hope that you have installed now the DuckDuckGo. And other thing, if you are feeling like the bored and you don't want to code this, then this project is already available at my GitHub repository. You can search there, Lakshmi Merit Langchain version 1 agents. So in version 1 agents, you will be getting this project. All right. So I'll make this public at the time of the publication of my video. And the link of this particular repository will be also given in the video description. You can get it from there. All right, let's go ahead and implement the tool here first of all. All right, so our web search tool need to be implemented. Let's go ahead and first import our environment variable. So why we need to import environment variable? There are certain settings which I have done in environment variable. You need to create it .env file. Then you have to set these things here so that we can trace our LLM execution at the LangSmith. So here you will be having your Langchain API key and thereafter the Langchain project v2. So this is the standard setting. You have to go to your LangSmith, then create the API key. So you need to basically come here, the LangSmith, then come to the setting. Here you will be coming to the API keys, then create the API key. Once you get the API key, then you have to put your API key here. All right, once you put your API key, now it is ready. Thereafter, you have to make sure that you install this .env as well. All right. So once you have installed the .env using the UV, so basically you can search this here in the UV itself, like here, .env, py, like this, python.env. So this is going to be like this only. You need to just copy this and then come here. Let me just write it here itself so that you can write it like this as well. UV add DDGS python.env as well. Once those things are done, then you can just simply import load.env. Then it is going to load your .env file in environment variables so that we can trace our executions. Thereafter, what you do here, you import the JSON, regex, temp file, all these things we will be needing later on. Don't worry about that. These are not going to be utilized immediately as it is, but later on we'll use once we implement all other tools like you see here. All these tools we will implement in coming lessons. Thereafter, you see you have your tools that is going to be imported from the Langchain core.tools. Then you get your tool. Then it is time to import our DuckDuckGo. All right, so we import our DDGS. After importing the DDGS, now what I do here that I'm gonna write standard method that is the web search. All right, so this is standard Python method, and this method is going to accept query as parameter in string form and then the total number of results. By default, total number of result is going to be the 5, but the LLM can also pass if it desired any specific number of result. Then this is the doc string. All right, so this doc string will be used for the LLM so that LLM can know which particular tool it need to call for any specific task or for any specific query. So this is your standard Python method. Now, to convert this standard Python method into the Langchain tool, you need to use this particular decorator. So we use this decorator that is coming from the Langchain core.tools, the import tool. Now it has become here a Langchain runnable basically, or you can say that here it has become here Langchain tool. All right. Thereafter, we are going to implement our result, basically it's the search query in a try and except block. So first we had imported already this DDGS. Then we implement .text here. So as you come here and see in the DDGS, you will be having your DDGS.text here. As you scroll it down, here you will be having. All right, so .text, as you scroll it down, you can see how you can perform the search here. This one, let me just scroll it down maybe a little bit more. So this is the class DDGS. It has this text. So this is how you write this DDGS.text, then your query and the max result, etc. and all other parameters. If you want, you can pass there. So this is how we implement our DDGS search. So we pass our query and that query is coming from this web search. Thereafter, we pass here the maximum number of result which we are going to utilize here. So we say that, okay, the maximum number of result is going to come here from here. By default, it is a 5. Then we decide that we are going to use here US and English language. That's the region. And then there is the time limit. So basically, the result which is going to come, that is going to be listed day-wise here. Thereafter, we are going to use these backends only. So we'll be using here, like, let me just show you here by scrolling it here. We'll be using here the backend, Google, Bing, and then we have Brave, Yahoo, Wikipedia, and the DuckDuckGo. Only these backends we are going to use. That's all. Now we get our result from here. Once you get your result, then we are going to check if result has been returned or not. If no result is returned, then what it is going to do, it is going to say that no result found for this particular query. Thereafter, we are going to format our result. So before we format our result, let's go ahead and quickly check the output, how this particular query is going to produce the result. So how we need to check this? Let's go ahead and quickly come back to our implementation here, basically this particular thing. So I'm just going to simply copy it from here. And then I come back here in this main.py. I'm just going to simply print this. Okay. I'm just going to paste it here. Let's go ahead and search this. Basically run this. Okay. So I'm going to run here. It's going to search for Python programming. All right. As you see here that the result is printed here. So it is going to come in the form of the list. So this result is a list. And in the list, it is going to be the list of the dictionary. In the dictionary, it has the title, it has the href. Basically, this is the link from where this is getting the result. And then it also has here the body. As you see there, these are the result here. All right, perfect. Now you know that how the result is returned by the DDGS. All right. So once you know how the result is returned by the DDGS, now we can process it. So this is our query. We say that, okay, the formatted result is going to be like this, search result for this particular query. And then we are going to add our result here. So we get our title, we get our body, we get our href, and thereafter we format our result like this. We have our title, then basically a number, basically how many results are going to come, so that we are going to return using this formatted result. Okay, ideally. So this is going to enumerate over the number of the result. So for first result, it is going to say here the like one dot, and then the title is going to be in the bold, and then you have body and these things here. Let me just simply, maybe I can do it like this only as well. Then you have your body and then the new result href. All right. And then you join everything, this list, and then it is going to return the result here. All right. Then you simply do here, you implement your exception basically, and then you return your result. That's all you have to do here. Once your web search is implemented, now it is time to test it. So before we test it, basically, we can just verify it once again. Let me just quickly take you through. So this is your web search. Now it has become the runnable here. So what the runnable means here? Runnable means that we can utilize Langchain invoke method to actually query, basically to invoke this web search method, what I want to tell here. So how you can do that? Let's go ahead and import this tool in our notebook. So this is our notebook, and it is going to import create agent and the tool here. So if you check these tools, basically tools.web search, which we had implemented some times back, now you will notice this tool is now structured tool, name is web search. This is going to be the description. So this description is actually used by the LLM to understand for which particular task it need to call this web search. All right. Perfect. Let's go ahead and invoke your web search. Now you can just simply invoke your web search with some query like earlier we had seen, like with the Python programming. As you execute this, you will see this particular answer. Let's go ahead and print it. Then you can understand that how we had done formatting. This is the search result. If you remember, in our tools, we had done formatting in that way. We had our numbering, we had our title in the bold, and then we had our body, and then we had our href. That is how we are going to get search result for Python programming. That was the query. And then we have our result in the bold. The title in the bold. Then we have our description here. As you see, this is the body about the Python programming, and here this is the link from where this particular description is coming. As you scroll it down, now you can see here all the description and the link and the title, all these things from where it is coming. And also here it is giving that the total basically 8 hours ago, and so the time, basically the time of the publication. All right, perfect. Now you know that how to implement basically a real-time web search tool. Once you have implemented your web search tool, now it is time to create your agent. If you remember, previously we had discussed here in our, let me just take the screenshot of this. Maybe that would be better to show you. All right, so I'm just going to take the screenshot of this, and then I'll explain you here using this particular screenshot. All right, so as you know here that our LLM accepts this prompt, it accepts the LLM, and it accepts the tool. Basically, agent accepts these three things. So to create our agent, what we have to do here, we have to give all these three things together. If you don't give the prompt, don't worry about that. It is going to assume the prompt by default, whatever the prompt we give there. So we provide here the prompt, and the default prompt is not provided. So it is just going to assume here a default prompt provided by the Langchain itself. I just need to find out here. Generally, the default prompts are you are helpful AI assistants. You are helpful AI assistant. That is the general the prompt. Later on, we will check this general prompt using our Langchain, LangSmith traces actually. So that part we will also check. The one thing you will notice here that this is the model string format. So you put your cursor here in the create agent, then you will notice here in our Langchain version 1, they have provided this special way. So one is the static model, basically. Another is the dynamic model. And in this way, what they are doing actually, they are providing it into a model string format. So what they do here that they provide their provider first. All right. So if you have OpenAI provider, you write there the OpenAI and then the column, the name of the model. So basically here it goes the provider. Langchain automatically behind the scene figure out that what are the things are here. And thereafter they provide this particular model name here. If you are running your Ollama on a remote server, then you can also provide there the base URL as well. You can also provide your base URL basically. They do have the access, basically they do have, the method to provide this base URL. All right. So they have those implementation as of now. All right. So now our agent is created. Let's go ahead and execute this. Now it is time to test our agent. Let's go ahead and test this. Then we will finally check our tracing at the LangSmith. So I'm just going to simply execute this. Let's go ahead and run this. So the result is going to be stored here in this result variable agent.invoke. It is accepting a message that is the search for Python tutorial. So it is going to search DuckDuckGo for the Python tutorial, and then it is going to provide the result. Let's go ahead and print this result. So I'm just going to print this result here. All right. So you have your result here. Now you have your messages, and after the messages, you have the list of the messages here. This is a very important thing. Later on, we will be inspecting this so many times in coming lessons. Basically, I'm just gonna print it here. All right. So you will notice all of these things. Let me just simply find out all these. Not like this. Maybe it would be better if I copy this one. Probably. I'm not sure. Let me just. This is human message basically. This is one thing. Thereafter, we have our tools message probably, or the tool message. I need to figure out. Yes, it is the tool message. All right. And I might be also having here the AI messages as well. Let me just find out with the Control Alt and Enter. All the AI messages are found. And then I'm just going to do it like this only. All right, so this is how I do this. Let me just put it here so that you can see the whole screen here. So you will notice this AI message. So basically, your agent is returning here messages. So this is the key here. All right, this is very important. If you know the Langgraph, in the Langgraph, you will know that there is the state. In that state, you have this message. So in that message, it is going to have here the list of the messages. All right. So all these messages are going to come here as the list. So first you have your human message. So this was your original query. With this, your LLM says that it need to call a tool here. So it calls a tool with type tool call. And the name of the tool is the web search. It is going to call the tool web search with this particular query, Python tutorials. Remember here, your LLM did not use the same query. It has modified the query, which is going to be suitable for your web search. Thereafter, tool gets executed, and then tool is returning here. Tool is returning the answer. So search result for Python tutorial, how should I start the Python? And then there are so many other things. All the results are returned here. Thereafter, this tool has returned the result as expected here. User query comes, LLM executed user query, it decides to call tool, and then tool returns the result to the LLM. Once tool returns the result to the LLM, then LLM is going to think here. So the think mode. So this Qwen 3 model, which we are currently using, that Qwen 3 model is actually the thinking model. So in that Qwen 3 model, you will have here a lot of thinking. So after a lot of thinking, then you will notice that it says that here are the top result for Python tutorial. Then it provides here the final result. All these results are provided here. All right, and then you will see we are using here Qwen 3 30 billion model, 30 billion parameter model. All right, perfect. So all these things, now you will notice everything here once we print our result. But if you want to inspect what has happened behind the scene, then how you can know that? So to understand that what is happening behind the scene, you can come here at the LangSmith. So in the LangSmith, you will notice with your project name, that is the agents. So that project name we had decided using this .env file, that is the project name, that is the agent here. All right. So we had decided that now we see our Langgraph has executed here. So basically our agent is actually the Langgraph. All right. So agent is implementation of the Langgraph. So our agent has executed. This was our message. And then this was human message. Basically, this was the human message. Search for Python tutorial. Then AI thinks there, LLM, and then it has called the tool, that is the web search. Thereafter, the web search has returned this particular result to the LLM, and then finally LLM got the result, and then it has finally produces this final answer. And you can see all these sequence, how the LLM is called and how the tools are called. Finally, if you click on the should continue, you will notice that it will produce the final end message here. So this you will notice this is going to end. But if you check here, then in this should continue, you will notice that it has produced here the output that is related to your tool call. Send node, basically the tool. So your LLM is saying that we need to call a tool, and the tool name is the web search. So this is the overall execution steps, how it is going to execute. And as I have told you that the code for this particular tutorial and for coming tutorials, so at least 10 to 12 tutorials we will be having in this Langchain version 1 agents, all those codes are going to come here. And once this video is published, then the playlist link will be also given here so that you can watch all the videos related to the Langchain version 1 agents. I hope that you have liked this video and you have enjoyed, and now you know that how to work with the agent. All right, so this is all about in this video. Bye-bye. Take care.